Okay, we're ready. This is the name of the company I work for as a machine learning engineer or machine learning consultant. This is the mobile advertisement company. So every time you open your mobile phone, any time of app, any kind of app, sorry, you might see some advertisement that is being sold or bought on mobile advertisement exchanges online. So this is never pre-cooked. It's like in 95% of the time just being sold instantly in quarter second or 100 milliseconds or stuff. And we are, let's switch the slide. We are somewhere in between of this nice system, trying to show you what you might like, trying to show you apps, what you might install. And as it's written here, we are being paid by companies, different companies who have their own mobile apps, and they want these apps to be installed by some people who like it. I'm not saying random people, because for random people, they don't need us. Just show it to everyone and hope it's gonna work. But if they need something more targeted, they might go to mobile advertisement companies and exchanges like us. And we have lots of data, well, comparably lots of data. I'm gonna show you compared to what, raw numbers and numbers that are related to something. What I do, I work with this data and create ways and pipelines, methods to make the data useful. Probably compress it somehow, make some kind of model that's gonna show how are you prone to install something. Should we show this advertisement type and this client to you or someone? I don't like using word you, because in fact we don't know if it's you or not. We don't have any personal data. We have some loose aggregations that might be some devices, people, or some group of people with the same interests. We're going to talk about this in a minute. But what we're going to talk about today is how it works, what data we have, and how you use your 3 petabytes of data to make any kind of model and push it into production. How do you learn your models with this amount of data? How to store it, how to use it, make pipelines that I mentioned before, and, well, some tech details, servers, storage systems, data processing, data retrieval, and models we use. I'm going to say the models is probably the least interesting topic, because there's nothing really special. The main challenge or the main question is, how do you work with this amount of data? So let's see. What mobile advertisement is, I showed you, or I told you before. Every time you open some kind of app, there are places for advertisements that are being sold on mobile advertisement exchanges with support, I guess, of your data that we know or that mobile advertisement gives to us. How it works, there's an advertisement, let's say company Apple with Apple Music. And there's wait a minute. I guess I need. I just don't understand why. Oh, yeah, right. You're on the right side. This is the supply. People who we might show the advertisement, ADs. And they are like their advertisement places are being shown on the advertisement exchange. We are on the left side. We are buying this advertisement. We are not selling places. So we get lots of advertisement requests. Like every time anyone in the world opens some app with place for advertisement, we most probably gonna see it with AD request, which says, would you like to show the advertisement to this, not this device, to this group of parameters, let's say. And we're gonna say yes, and say like we're gonna pay 10 cents, or we say no, or we're gonna pay $1 for this. We'll see what data we see in the advertisement request. Quite interesting topic. We see operating system type, We see its version, we see device model, we know if it's iPhone or if it's Android or some kind of other operating system. I don't know, something from Microsoft, but they're mostly non-existent. We see screen size, IP address sometimes. Of course, we see target application name, the application we're gonna show the advertisement in. What's this? What are you using right now? What did you open? Is it some casual game, or is it again some Amazon Music, and in this case Apple Music would like to show you something? And sometimes, I'm saying sometimes, device ID. Device ID is a unique identifier of your device, not of you personally, of your device. This being blocked by Apple some months ago, I guess probably half a year ago. So now because Apple cares of your privacy, as they say. So now we don't really know about anything about Apple devices. We cannot match you with what you've done before. We don't really know, have we seen you before or not? But this still works on Android, but I bet they're gonna somehow block it too. So this is why I'm saying sometimes it's just a type of like a profile, a loose aggregation. We are not really sure, is it you again or is it not? And who are you? Because, well, you might see the amount of data that we get is really low, probably. We don't know anything personal about you, but we can use it to get some more. We can understand the country and the city this device is in now by IP address. We might see with time all the apps that this device has. How? We just track all the apps that being opened and shown some advertisement places with the same device ID, if we see it. And we know that with this device ID, this guy used during the last 6 months a number of apps, like 30 apps where we being offered to show advertisements. And we can get the frequency of using some apps and the overall number. And this is the main source of information for us, actually. We don't have anything else. We're not like Google or Facebook. We don't know anything about your name, your profile and stuff. And gender, age, again, we can infer this from the type of apps you're using. Some other stuff that I cannot really discuss, not because this is illegal, but mostly because this is some know-how that we have. So I'm gonna just put some smiles with legs here. And we're gonna discuss what is never known by us, what everyone's afraid of, like your name, eye color, selfies, contacts, passport number. We don't know, we know nothing about it, and we actually don't care because this is meaningless for us. This might be useful for, let's say, Facebook, because they have their own data, and knowing your name, they can match your activity with your activity in your profile and know whatever they want about you, what's your interests, what photos you like, who you connect with in their own social network. I mean, if you have your own social network, knowing your device IDs and matching users is crucial. If you're guys like us, you don't really need it. So all of this is not about us. And that was a brief introduction of how mobile advertisement works, for you just to understand what we're going to talk about and why we use this data. So our goal, as I said before, probably is to show relevant advertisement to people who are interested in it. Like if our client is, I don't know, online dating app, we're gonna try to show it to someone who's interested in having a relationship. That's should be quite easy to understand. Or to someone who's gonna probably install it and it's gonna be cheap for us. This is the second side. The cheap clients are clients too. And this depends on the competition on the market, time of day and stuff, and for all of this we need data. But as I said, we have right now around 3 petabytes of data and 3 billion profiles. So you can say loosely that we track 3 billion devices out of, I don't know, probably 10 billion devices in the world. I'm not sure about the exact number, honestly. Probably it's 6 or 7 or 10, but this is a good proportion. Yeah. And how this works? This is a bird's eye overview of the structure. I hope some of you are common with words that are written here. So I told you before, bid request is the thing that we get from advertisement exchange, basically asking us, there are some parameters about this device. Would you like to show any of your advertisement stuff to this device, and how much would you pay? So we get bombed by bid requests, probably some millions per second. 3-5 millions per second. This all goes to Kafka as a dispatcher, and we put it raw in ClickHouse cluster, which is probably the heart of our data. It's quite big. We're going to discuss it in the next slide, but now it's just easy to say that we put everything we listen to, 3 million requests per second in ClickHouse, and we don't really care how is it stored here. There is a layer where it is just raw, and we store it for 10 days only, because this is a crazy amount. We cannot afford storing like last month's or 3 months of bid requests. What we do aggregations. We take what we need from this data and we store aggregations for like 3 months or a year or stuff. So we have lots of different layers, but this is the next slide, what it's all about. Apart from storing data, there's a nice thing to do. We should give answers probably, right? Otherwise, they would not send us any requests. So for answers, we have bidders. This is a separate machines, a cluster of separate machines, again, around 70 machines, that what they do, they run models, and these models answer to bid requests. So we enrich bid requests with the data that we have from our ClickHouse cluster, like time series data, some data about, we're going to discuss it later. And these bidders give requests in, I would say, 2 to 10 milliseconds probably, quite fast. This is what we need to be competitive, but not like fractions of milliseconds, no one cares. This is not like high frequency trading. And how we do features, how we generate them, it's all being orchestrated by Airflow, and we store all the features in almost all the features in our ClickHouse cluster, which is, as I said, quite big, but features that we need for models to give actual answers to bid requests, we store in a hot database. So you see it's not like bluish, it's more to the yellow. This is Spike. Some of you might be common with this database. This is a key-value storage. So all of the data is in your RAM, operative memory, and it is fast. It's quite expensive to store your data in operative memory for sure, but we store a small subset, the actual features, and they interact with bidders. Is it more or less clear? Okay, let's switch the slide and talk in deep about our main storage, ClickHouse. What I say about 3 petabytes is only if you count it uncompressed. And this is like, there is no reason nowadays to store any data uncompressed in database, as far as I think. So actually it's 1.7 petabytes compressed, if you count disk space that we have. And it's 200 machines. Quite small machines, I would say. No multi-socket epic AMD stuff, just like 32 to 64 gigabytes of operative memory, 1 HDD, no SSDs again. I would say that for such clusters, you don't need SSD disks really. And well, of course, it is sharded and replicated, because with this amounts of data and with these numbers of machines, you don't have any other opportunity. This is just, well, this is just number one thing you should do to have your data consistency and to have your speed of writing, probably speed of reading, but mostly speed of writing, because as I told you, we have to store all the bid requests just in case. Why 3 petabytes? Not because this 10 days of bid requests take 3 petabytes, not really. Mostly because for speed, we use lots of materialized views, projections, and stuff to not use any joins or complicated queries in this cluster. So whatever we need, I am exaggerating a bit, but for every type of common query, you have your own materialized view or projection or table that is pre-calculated. So when you run this query, it just takes the half-finished or pre-cooked data. You don't need to calculate anything really, because, well, this is a trade-off. You can use more space to pre-calculate it on the fly and store it, and less computing power. This is what we do. Or like, okay, space-time trade-off. Or you can choose the other side and you say, okay, space is quite expensive. I wouldn't store any other projections. I'm going to normalize everything like they teach you in the university with databases. I'm going to have everything in normalized form and use really complicated SQL queries to create the data that I need. Doesn't work for us. I'm not advocating that this is the best choice, but this is how we do. And again, if you have any questions like on the tech side, I'm not going really deep into tech side. You can ask me afterwards. I'm quite free to discuss it or answer as far as my knowledge goes, let's say. And another nice thing that I was quite interested or probably even shocked is geography of your clusters and database systems and bidders, given that we work worldwide. Normally, and feels normal to distribute your cluster across the globe because you have clients in China, you have clients in the US, you have some guys in Europe like you who open their mobile phones and watch some advertisement. And it seems logical that you have a number of clusters around the world to be fast because we need to be fast. You cannot afford waiting half a second for your advertisement to load. No one can afford. We have like 100 milliseconds or probably 60 milliseconds for the answer. And what happened in fact? We tried let's say multi-place clusters, and we didn't find it working really well for us. Why? We have, as I said, 70 separate bidder machines, one big cluster of databases, and we normally give a 10 milliseconds response time, and well, the speed of light, you know, you need around, well, 70 milliseconds to pin someone on the other side of the globe, but it never works like the speed of light, so it's 100 milliseconds and stuff. So you might lose some clients if you have only one place for your cluster, but what you get instead. See, this is the 24 hours of our load, and you see we have number of peaks, namely 2 peaks. I guess this is the US time, and this is the time from Asia, like China, India, and stuff, 2 biggest markets for us. Why peaks? Because people are active when sun is up, and sun goes around the globe. So you don't really, as we see, you don't really need to like have your computing power distributed evenly. You can place it somewhere where you have the highest peak. For us, this is the US, and we have all of our servers here. And if you do it, what nice is you don't have to spend twice money on your cluster, because if you need the second cluster, you need the second group of bidders, because see, the peaks are more or less even. So you need twice the computing power if you want to care about 2 peaks separately. And if you have one cluster, you just care about this peak, so you have 100% computing power, and this works in the same way. So you cut your costs by double, having money to be faster, to probably have faster databases and bidders, and compensate this time lag, this ping between 2 locations. That's what I would never think about, because normally you think it should be distributed, but there are cases where it shouldn't be distributed really, because you just waste your money for no reason. And still puzzles me that it works better when you have everything in one place. I hope I am clear in terms of costs and stuff, right? Okay, let's make a step. We talked about data a bit and clusters and the amount of data that we have, but we now gonna pay attention to what actually we use in our models. And models, I would repeat a bit, they predict the probability, this is an oversimplification, but still they predict the probability of someone to click on our advertisement or to install some app. So we need a number of features to do it that we generate somehow. And what we try to do to not being killed by the necessity to have big amount of computing power, we try to use as less online features as possible. Online features is features that you have to calculate right now in the time of your bid request, and you have literally 10 milliseconds to do it. This is like solid challenge, and probably you can get rid of this challenge if you have online only what is orange here. Simple counters. What's counters? Let's say this is how many times this guy already seen our advertisement. Every time we show something to someone, we make some mark in the database, namely in Airflow, and it's fast. You just count it. Just numbers. They're used as features. You don't need to calculate anything. You just keep counters and sets. Set is, as I said, when we know, when we can track someone and have the set of applications that this person or aggregation or device has on its phone. This is the set. We just add some new applications if we see them, or we delete something if we haven't seen something like for half a year from this ID. This is sets and moving average and slopes for time series. We have some time series of, well, it doesn't really matter of what, but we never use time series as raw features, and we never make any kind of embeddings or stuff on time series. We only keep moving averages and slopes in our Aerospike database, and we keep roll time series and ClickHouse. They are not features. So we probably pre-calculate something with ClickHouse and update it every time some action happens, and we put it in Aerospike. And in the time of model inference, you just ask Aerospike for this number. What's slope, what's average, what's stuff, no calculation, it gives it to you again. And next, we have text and we have pictures, somehow, not mentioned in bid requests, but if we know that you use some app, we know that there are screenshots of this app. We know that there are pictures with descriptions, and we try to match your like text and pictures and stuff with the application we're gonna show this advertisement in. So we don't really store pictures and text. We store only vectors in ClickHouse, which is the main cluster. But we never give the full vectors to Aerospike. We compress them. So normally have vectors like, I don't know, with a length of 1000, 512, and whatever. We compress them to small vectors like 10, 16, 100, I mean in terms of length. And we even not always use vectors as features, like because every vector is 100 of new numbers. This might be too much for online processing, for inference. We calculate cosine distances between vectors, and we, in the end, you had a vector of 500 of elements, and you end up with one number, which is your feature. This is the cosine distance, and it works more or less okay. Yeah, I would say compare it to computation power that we save, not using raw vectors, it works great. And as I told in the beginning, vectors and embeddings and stuff updated offline based on Airflow schedules. So we store raw vectors in ClickHouse, we update them. Some of them are updated once a day, some once a week. Offline, like nothing triggers it apart from Airflow schedule. And then we use it in our models. And I'm gonna pay a bit of attention to vectors compression. This is quite interesting topic, as it turned out. This is high dimension space of BERT processed text. Some of you might know what's BERT type of models. This is models for natural language processing that you give a set of like some sentences to it, and it produces the embedding for the sentences or sentence. And normally it has a length of 7, 6, 8 elements. And if we visualize some corpus of our text in a 2D dimension, it looks like this. You see some clusters, you see some galaxies, stars, looks nice. And we never use this length of vector, so we compress it to 10. And if you use linear compression, namely PCA, which is considered a standard, what you get is this type of muddy stuff where you lost all of your stars and galaxies and clusters. It still works. It works okay, and we used it until some point in time when we tried to use some non-linear compression, different types. But what we use now is UMAP, and I'm not going to tech details, but this is a quite well-known method to compress well and visualize vectors, and the same vector of dimension of 10 compressed with UMAP, not PCA, looks like this. You have everything you need, I guess. You have clusters and whatever you didn't. Well, of course, you lost a lot, but it doesn't look as just a, I don't know, pile of dirt, right? Looks enough for your model. Looks good, actually. So, yeah.
Quick question. So, did you use this two-dimensional embedding to validate whether this is a good compression or not? Or?
We use 10-dimensional.
Yeah, but you're like compressing to 10 dimensions, and then you kind of visualize it, right?
Yeah.
Some other non-linear methods, right? I guess.
Yes.
And then you use the picture to assess the model quality of this compression step.
Well, the picture was the first that we used, but afterwards, of course, you cannot make decisions like production-related decisions on how your picture's looking good or not. Yeah, no. Of course, we ran like a number of A/B tests. We trained some models. We've seen that our area under the curve for models with better vectors is higher. So, like normally, you test it offline with training models. If it works, like any new feature, any new vector, if it works offline, so you see your metrics for your models are better, you then test it online with A/B tests, splits, and you see what's your business metrics. Like if it's actually buying your traffic cheaper or buying it with bigger quality. Yeah, but I don't have time, and I don't think anyone's interested in like stuff like what's the price for a traffic. No, pictures work better in terms of presentations. And I guess here's the last part of our discussion. Sorry, my presentation. We haven't started the discussion yet. The models that we use, the least interesting part, because there is no surprises. We use gradient boostings for the main bidding because our data, our features are mostly tabular. And tabular data, you might know that gradient boostings are still kings of tabular data and like predictions based on tabular data. We tried different neural networks and stuff, but first of all, they are slower, but this could be beaten by having smaller neural networks, but when you have small neural networks, they don't work as good as your boosted trees. So we stopped on gradient boostings, and I don't see any opportunity to switch to neural network, at least with our structure now. And we use some BERT-like models for NLP features, so we just compress text and vectors. This is made offline, and there is nothing to discuss. I'm not even sure which type of BERT model we use. Doesn't really matter. We use Clip for image features, a really, really good one if you need to get embeddings from your pictures. We tried stuff like ResNets, we tried some UNets, as far as I remember, making encoded features, but Clip works best for us. We have some small amount of embeddings, and we use attention encoders, decoders for it. Nothing special again, nothing to, like, no secrets to tell, honestly. And we use small MLPs for reinforcement learning for our bidding systems. You need it, well, not everything you can get from your offline features. Sometimes you have to try something online, see the impact, get the response, and tune your features or models. We use simple reinforcement learning for this. Quite interesting topic, but not this time. Uh, well, you might be impressed by numbers like petabytes of data and stuff, but what I can tell you is what I know from public sources. Around 10 years ago, Google, whose main business is selling advertisements, of course, and I guess main source of revenue, had around 15 exabytes, which is some thousands of times more than we have now. So, well, we actually have nothing, and we know nothing about our clients or whatever compared to really big guys like Google or Facebook or whoever who has its own social networks or can track actions of, like, let's say, who has its own platforms, right? Google search, YouTube, they know everything, what you do, what you like, what you see, what you look for on Google engine search, and they use it to show you some relevant advertisement. I mean, I'm not saying it's bad, but you can opt out from this stuff by, if you have the Apple phone, you can just ask any app to not track you. You've seen this probably. When you press it, this app would never say your Apple ID to guys like us or Google or Facebook, to anyone. And in this case, we cannot track the history of your actions in this app. We know nothing about you, and we're gonna show you some irrelevant stuff, like literally something that you never expect to see, some cheap stuff, because if there's no ID, you know, this probably wouldn't work, and we show some cheap unrelated stuff like I don't know, like betting or like really half scam advertisements that work only when you show it to millions of people for cheap price, and some gonna install it. You don't have to target. So I personally always click allow because I know how it works and it works better for me. Like you may call it a bias, but this is what I do. And now you know what this button actually does. I guess that's all. I hope it was interesting. And if you have some questions, I'm ready to answer. Yes. Oh, this is the first question. Okay, thank you.
Thank you, very interesting talk. First question, I'm not at that business at all, but you mentioned multiple times if advertisement is relevant.
Yeah.
How do you know it's relevant? Like, how do you measure that? And how do you know, like, your model, let's say, I mean, when you trained it, it's clear how I understand that the model is better than the previous
Yeah.
model. But how do you know that it performs in production better than the previous model?
Well, as I say, we run A/B tests. We just split the traffic. We have old model, we have new or
Yeah, like, I mean, I'm newbie here, as I said. So if I click on the ad, you know that I clicked on it. And that's
yes, we know. We know that you clicked. We know, well, if we being paid for clicks, this is a success. But this doesn't exist now. We mostly paid by install. If you install the app,
okay.
in this case, we get our money. If someone just clicked, we get nothing. So we are not relying on clicks, we are relying on installs. And there's another interesting topic, the click fraud. There are like farms of bots with like thousands of mobile phones somewhere in China or other countries who just click somewhere and just like they pretend to be companies like us, so they make artificial clicks, sell it to customer and get money, but there is no real human behind the click. These are just like bots. So no one pays for clicks now. This just doesn't work. Anything else? Yeah.
I have more. I just don't want to.
Yeah. Okay.
Okay, you mentioned that kind of that you know which apps I installed.
Yeah.
I in the sense of like in your features. Let's
Yes,
say.
yes.
So me as a person, but
Yeah.
does that mean that you can have some kind of customer profiles? So
That's right. That's what we're doing.
How many of them are approximately there? I'm just wondering.
How many of who?
Profiles do you have?
Like 3 billion customer profiles, as I said. Yes, yes, yes. But this is not always the same person, or there might be like a group of persons with same habitats and interests who are all fallen in the same customer profile. Because we don't know if it's a real person, if it's a number of persons, or
Thanks.
yes, yeah.
So you mentioned instead of keeping vectors of features, you keep a cosine distance of vectors. So what do you take cosine distance between which vectors actually you have to?
Okay, that's easy. Look, let's say we have apps that you have on your phone, right? You didn't deny any app to be shown with ID, like I showed, and we know that you use like your top 5 apps in terms of frequency that you use it is like app 1, 2, 3, 4, and we literally take text descriptions from App Store for your top 5 apps. We compress these descriptions into vectors. We take weighted average of your text vectors, weighted by how often you use your app, right? And this is the text vector that describes your apps, all of your apps. We compress it into one vector, yes, with weighted average. This is vector number 1. And vector number 2 could be, let's say, the text description of the app that we're gonna advertise, right? We compress it, and we have 2 vectors, and the first vector is, let's say, the profile of like descriptions of your apps that you have, and the second vector is the profile of app that we might show you or may not, and the cosine distance is, well, how close they are. Or you can take the vector of the app where the advertisement gonna be shown that you opened right now, and calculate the cosine distance between description of app that you opened and the app that we're gonna advertise here in your app. Like some number of ways, but it's always about applications. Pictures, same, you have screenshots of your applications, and we show you banners or videos or whatever graphic stuff that can be compressed into vector description too. Yes?
Seems like your input features are like highly hand engineers most of the time. Like you try to keep it fast, and seems like you try different models and see what works best to like get your input features.
Yeah, this is what I do.
Yeah.
Yeah.
Have you ever like do you always do that just by hand, or do you also have like I don't know, like automated feature search where you can try out different features in a way?
Not really.
Or something offline.
Not really. What we do is someone got the idea of new feature, like vectors matching, and you create it on a small subset of data, not taking it into the production, and then you test it offline with just building models, with having new feature added on old traffic that you had, and see if they like okay with predicting who's clicked, because you know who's clicked. This is the data from a month ago. You'd like shown whatever, and you know who's clicked, who's not. And if they're predicting it better than your current model, like having new feature improves your click prediction probability, right? Not probability, but okay, you got me anyway. I just don't want to go into deep side of like what metrics we use. This is irrelevant. So if you see that new feature works offline, predicting clicks that happened already, you may take it to online testing and split your traffic between old model and new model and see if it works in terms of business metrics. If for the same amount of money spent, you get more clicks or more installs, or I don't know. Sometimes you're being paid not by installs, but by money spent in the application. This is the hardest case for us, because you may have lots of installs from people who literally have no money to spend and this doesn't work, or you may have some small number of installs from people who spend like hundreds of dollars in the application and this works. So anyway you have to test it online in the end.
So follow-up question, now you also use some like fairly new models like Clip and Bird or whatever.
Yeah.
Do you have like a process to, I don't know, look at new models, or you just, because the machine learning space is like evolving so quickly, do you just read papers regularly, or do you have any kind of like...
Yeah, what I read is papers with code.com. You probably know the site where like all the top stuff, all the state-of-the-art stuff is tracked. Or I hear from some people somewhere that there's something new, and we try it. I try it. Yes.
It's mainly you just read up.
So, yeah, we have a data science team that like quite small, 4 guys for this amount of data. Yeah, and that's what we do. You had a question?
Yeah, I was wondering if you opt out and you say you're not allowed to track the device ID. Kind of data sets like you mentioned, the last 5 apps that you most frequently use. Are you able to access those information, or what?
No, because we don't know if it's you using this app or not. We cannot track your activity in time. But well, we try by your IP address, by like patterns that you exhibit, and somehow a so-called fingerprinting. That's what everyone does now. But well, we can say it doesn't work. It doesn't really work. No. So that's why I say 50% of our profiles, they are not, I believe they are not like separate unique devices. This is more of class of devices and people who exhibit the same patterns in activity. Yeah?
How did the how did the model react during the pandemic? Like I'm thinking about the wine industry where the dynamic pricing basically completely wasn't, the model didn't work anymore. Was it still working, just in a bigger volume, or did you see some?
It was okay. I wouldn't say something got worse. Like the advertisement industry, of course, online advertisement, got a big bump from the pandemic. We got more money, more clients, more stuff. We had some growth during this. We have growth even now, yeah. But it was for good for us. And then we saw some drawback, of course. But from the tech side, I wouldn't say we we saw someone that needed to take some measures or change something or something stopped working. No, it was okay. But I guess I know what you talk about when you buy your when you spend your money on advertisement on platforms like Google or Yahoo or somewhere. They had problems with, like, before pandemic you used to get your clients for $1 and now it's $5 per client, and this is like, whoa. Yeah, there were spikes of prices. Yeah, but this is the other side. I mean, clients, for us this, it doesn't matter. Yeah, see you.
Hey, thank you for the talk. I have a couple of questions, but if there are discussions on, feel free to decline. We will discuss later. So first of all, about ad blockers, right? So do you use some data that the client has your ad blocked? And
No,
do you use it?
no, we don't. We don't care about it, like, at all. Which again, we would just see that this type of profile or this device ID doesn't give us any meaningful conversions or clicks, and model would have to automatically decide that there is better not to show anything to this guy. So we don't have anything spatial, it works by itself.
Okay. Another question is about well, those not paid clicks you mentioned. I know there are some programs like those ad blockers that click themselves on the ad,
Mhm.
and yeah, so they some kind of spoil
Mhm. Mhm.
the data of the client, and probably yeah they also make some money transfers, but you say nobody now pays for it.
Yeah,
Just clicks.
no one
So
paid for
you
clicks.
use clicks in the model somehow.
Sorry, I
You
missed.
use the clicks in the model.
Not everywhere, and I would say if you ask me in person how I would rate our usage of clicks on a scale from 0 to 100%, like we use installs for 100%. This is like absolutely good one, and for clicks it's like 15%. So we added somewhere sometimes, but there is not a single pipeline that uses clicks everywhere and every time. No, they are not really relevant because of lots of fraud, AD blockers and clickers and whatever.
And the last question is about a frequent situation that I have, and I heard people have, like I could Google something like buy a chair and go to IKEA and buy it actually,
Mhm.
and then for a couple of weeks after it, I see ads about chairs.
Cheers.
Yeah, and they suggest me to buy it. So what is it?
This is just algorithms being stupid. They don't know that you bought it already. They saw that you exhibit activity that means that you are interested in furniture or chairs. And in this case, they show you chairs and furniture, but no one knows that you bought it already. And when you show no reaction for this furniture stuff, they gradually gonna stop showing your furniture. Like you're not saying, "Hey, I have a chair already." There is no button to say it, right? We have to guess it. After we show you like 20 times some chairs and sofas and IKEA stuff, we see that you show no reaction. Okay, this is not a chair, guys. Stop it.
So you have such problems in your model too, or?
I guess everyone has, but there is nothing special to do about it. You just show it, and if it doesn't work, your model gonna understand this client is not interested in chairs anymore. Okay, yeah. So there is no spatial pipeline to tackle it, to fix it. No.
Is there some kind of term for this problem? Because it's quite common. Probably there is a name for it.
No, there's no term, and I wouldn't say it is common for us. I mean, this is a bit too granular to work with. We don't even see these problems. Probably, I mean, as machine learning engineers, probably some buyers. These are people who work with clients and like use models. They might see it, but again, you you don't know. Like if you ask me, if you give me your Apple ID, let's say, yes, and ask me, tell me about my interests. I wouldn't tell you anyone. These are just some numbers, vectors, actions, stuff. How would I guess that this is chair? I have to, I don't know, create text descriptions of chairs or pictures of chairs, turn them into vectors, and try if they match with your like. We actually know nothing in terms of human domain knowledge about our IDs or profiles or stuff. This is all. What you need is numbers for models, and they cannot be interpreted by humans like me or you. So, I mean, we don't have like in our databases we don't have categories like chair lovers or beer enjoyers or like no. Yeah.
This is sound maybe stupid, but did you already hear about like fraud on the install side? Like people, I don't know, somewhere.
Fraud on the install side.
Yeah, because fraud clicking, yeah, that's quite obvious.
Yeah, it exists. It exists. Yeah, with well, by the same people who earn by being like fake advertisement platforms, and they use sophisticated stuff to actually install the apps. So they're like fake devices. They click and they install the app, but they never do anything apart from it, and they get paid by installs. Yeah. Sometimes it is, I wouldn't say it's a big problem for us. The problem is when you see such data that someone's really good at installing apps, your model might target to this type of audience, and this type of audience is just like fraudsters. And you sell these installs to your client, and the client says, well, the traffic from you is dead. They install, but nothing happens. They don't like buy our fancy skins for Counter-Strike, or they don't do anything in apps. Like, you sell us fake installs, sorry, bye. So it happens sometimes, but this is not the biggest problem and biggest challenge. Yes?
Okay, let's see if I can. I wonder when I click and I change my profiles, kind of. I wonder, do you also work on aggregations of profiles? Like, is it just something you indirectly have, like an app that only works in Germany, for example, via the distance and the vectors, or do you also do some kind of aggregations of, like, when I click something, I affect some aggregated group I would be similar to something like that?
We don't do it directly, but as I said, if you don't have your device ID shown, we cannot really know that it's you, and you fall into some category, probably some aggregation of by your activity patterns, by your IP address, by your device model, and like version of your operating system of your device. So it happens naturally, yes. Some of our ID are just aggregations of some people. I don't know how many people are inside, you never know. Yeah, but we don't do it manually. Probably buyers, the people who actually run the advertisement campaigns, I mean, like they are our employees, they may have some their aggregations in terms of they had a client who wanted to advertise chairs, and the client spent some $100,000 for it, and now you have a database of people who clicked or who installed, who bought. We know like their IDs, and you can offload these IDs and have some millions of IDs of people who are interested in chairs, and they may use this base of IDs directly, saying we're going to show only to these IDs because we know the ones were interested in chairs. Or they may use some tools that we data scientists made to get the vector description of this million of IDs and to match IDs that look alike, like the people who like bought these chairs before.
Guys, let's have a break for a pizza. And if you have any other questions, you can ask Vsevolod in private.
Yeah. Okay, thank you for now.